Hello, today we are going to look at how to solve quadratic equations by factoring. And we're going to see why factoring is our friend. So we've already looked at how to solve a linear equation, and some students get stuck there. But when you're solving a quadratic equation, you don't use the same methods that you use when you're solving a linear equation. So solving quadratic equation uses a different method that we use for linear degree 1 equations. A quadratic equation has an x squared term, and a linear equation has just an x term. So if you see an x squared, that's quadratic. If you see x to the 1, that's linear. So quadratic equations are degree 2 equations. So we need a different method. And the way we're going to do that is we're going to use factoring to break them down into linear expressions, which we will then turn into linear equations. We need a very important property. It's called the zero product property, and it's worth knowing the name of it and worth knowing it because it reminds us how we're going to solve a quadratic. So the zero product property says that if you have two numbers multiplied together, okay, so some number A times some number B, and it equals 0, then the property of 0 means that if you're multiplying two numbers together, the only way the answer can be 0 is if either A equals 0 or B equals 0. So that's the zero product property. That's the property we're going to use. So these are the steps for solving a factorable quadratic equation. So the first part is you always want to notice that it's quadratic. And then if it is, you want to set it equal to 0. Okay, that's this part. We want to use the zero product property, so we want to set it equal to 0. Then we're going to use factoring, because when you factor a quadratic equation, it factors into two linear expressions. Okay, so that gives us this part, the product. These are factors. So we're trying to set up this if part of the zero product property, and then we'll set each of the factors equal to 0. And then we're going to solve. Okay, so if you never make the change and you don't notice that this is not linear, you might think it's good that the 18 is over here, but it's not. It's quadratic. So step 1 is we want to move this 18 term over here. So that's x squared minus 7x. That positive 18, move it over the equal sign, it becomes a minus 18. And then once that's gone, you have the 0 placeholder. So step 1, you set the quadratic equation equal to 0. Factor it. So it's an easy one to factor in that there's an understood 1 here, so we know it's x and x. We want to check the factors of 18, 1 and 18, 2 and 9, 3 and 6. And we want to know which one subtract to be 7, which is 2 and 9. Okay, now what we want is we want these two to add up to be a negative 7. So negative 9 plus 2 gives you a negative 7. So now we have the zero product property set up. This is our A times B. That's why we have to factor equals 0. And if A times B equals 0, then either A equals 0, or, which is x minus 9, or B equals 0, which is x plus 2 equals 0. So then you solve these two linear equations. On this side we'll add 9. We get x equals 9. And this equation we're going to subtract 2 from both sides and get x equals negative 2. So this quadratic equation has two solutions. We can check the work here. If we put 9 in here, we get 81 minus 7 times 9, which is 63. And that does give us 18. But if we try -2 and put -2 in here, quantity squared, that's +4. Minus 7 times -2, that's +14. And that also equals 18. The other thing, we haven't graphed much, but if you were to graph this in Desmos, that's a quadratic, and all quadratics look like a U, either opening up or down. And these solutions are also the x-intercepts of the quadratic. So if we were to graph this, it would look like this in Desmos. So these x-intercepts correspond to where it equals 0. Okay, so that's how you solve a quadratic equation by factoring. Step 1, you set equal to 0. So we're going to move this 14 over here. See, we notice it's quadratic. See the p squared? You got to start looking for that. So we set it equal to 0. And then we're going to factor. And since it's just p squared, we know it's p. And the factors of 14 are 1 and 14, 2 and 7. That subtract to be a -5 or -7 and +2. So here we have that zero product property set up here. This is why factoring is our friend. We like this product, a zero product property. If we can get a times b equals 0, then either a equals 0 or b equals 0. So next step, we set each linear factor equal to 0, and you get p equals 7 or p equals -2. And you can check that. All right, let's move to number 3. So here, see this x squared, this makes it quadratic. Now, in order for us to solve by factoring, we have to make sure that our quadratic is in descending order. So ax squared plus bx plus c equals 0. And the reason I'm mentioning that is because this 5x does need to go over on the side, but we want to write it in descending order. So 3x squared, and then don't write the 2, instead write the minus 5x. When you move it over the equal sign, it becomes the opposite sign. 2 isn't moving, so it stays positive. 3x squared minus 5x plus 2 equals 0. So we've got it set equal to 0. Now we're going to factor it. This is a medium difficulty one. We have to worry about this 3x squared being 3x and x, and 2 is 1 times 2. And because this is not even now, this is the 3x and this x, we have to try the outer and the inner terms. They have to add to be 5. Okay, so if I put 1 here and 2 here, that's 6x and 1x, and they do not add to be 5. They subtract to be 5. So that's not right. That's a tricky one. You got to be very careful. So let's switch it and make 2 and 1. Then that outer term would be 3x, and that inner term would be 2x, and they add to be 5. Okay, last thing we want to add to be a -5. So the signs are going to be -3x, -2x. So we get a negative and a negative. Okay, then we're ready to apply the zero product property, which means if you've got a times b equals 0, then either a equals 0 or b equals 0. So 3x minus 2 equals 0, or x minus 1 equals 0. So here we have a linear equation. We first add 2 to both sides. That gives us 3x equals 2. And then we're going to divide both sides by 3, and that gives us x equals 3 over 2. And over here, if we add 1 to both sides, we get x equals 1. So we get 3/2 and 1 as our solutions. All right, number 4. If you're ready to try it, pause the video and try it. Okay, it's already set equal to 0, so step 1 is done. We'll try to factor it. So the factors of 5, 1 and 5. So I know that's 5x and x. And the factors of 6, 1 times 6, 2 times 3. And I've got to check the outer and inner terms and get them to subtract to be 7. So I'm going to try 2 and 3 first, and let's do that. 5x and 2, that's 10x. 3 times x, that's 3x, and they subtract to be 7. So we have the right numbers. Now we'll do the sign. We want it to be a positive 7, so when this is a minus, these are going to be different signs. So we want this 10 to be positive and the 3 to be negative, so we get positive 7. So that 10x came from 5x times 2, and that negative 3x came from minus 3 times x. Okay, so we've got it factored. Then we set each of the factors equal to 0. So a quadratic is factored into two linear expressions. We set them up. They're linear equations, and now we can solve them. So that's 5x equals 3. X is 3 over 5. X is negative 2. So we now solve for x. We know what the values of x are that make that equation true. All right, so number 5 is not quadratic. If you're paying attention, you should notice that it's into the fourth. But we shouldn't let that stop us, because the zero product property is true for any amount of factors. So if you have a times b times c equals 0, then either a equals 0, b equals 0, or c equals 0. So even if it's not quadratic, we still want to start by setting it equal to 0 to see if we can factor it. So we're going to move the 60n squared over. So that would be 21n to the fourth plus 12n cubed minus 60n squared equals 0. And then if you remembered your factoring checklist, we can check for a GCF, which is often going to be a way to reduce something down to a quadratic. But let's look at the numbers first. We have 3 times 7 is 21, and 3 times 4 is 12, and 3 times 20 is 60. So we can pull out a 3, but more importantly, you have an n to the fourth, n to the third, and n to the 2. So you can pull out an n squared, which will reduce this trinomial down to 21n to the fourth divided by 3n squared is 7n squared. 12n cubed divided by 3n squared is 4n. Minus 60n squared divided by 3n squared is minus 20. So see how we've got this quadratic here. All right, so we need to try to factor that. That's going to factor into, it's a medium one, 7n squared, so we know that's 7n and that's n. Then if we check the factors of 20, we have 1 and 20, 2 and 10, 4 and 5. And we're going to check to see which of these give you outer and inner terms that subtract to be 4. So, just going to do it in my head. Looks like 10 and 2 are going to work. And you want them to subtract to be positive 4. So 14n and 10n. 14 needs to be positive and 10 needs to be negative. So that would be a minus 10 and a plus 2. So now we have 3 factors. We have 3n squared times 7n minus 10 times n plus 2 equals 0, so we can employ the zero product property. So 3n squared equals 0, divide by 3, and you get n squared equals 0, but n is 0. All right, 7n minus 10 equals 0 gives us n equals 10 over 7. N plus 2 equals 0 will give us n equals 2. So we have 3 solutions this time. And we'll talk more about this later, but this n squared is really n times n. So n equals 0 is one root. We call it a double root, multiplicity 2. We'll talk more about that later. All right, number 6, I just put down here just to see if you notice something different. Look at the directions. Notice that it says factor instead of solve. Notice how it doesn't have an equal to. So you can't turn an expression into an equation. So we're not solving for x here, we're just factoring. So you have to pay attention to that. All right, there's 4 terms, so we can factor this by grouping. We can pull out what from these 2 terms? 5x squared, and that leaves us with x plus 2. And then minus 4x minus 8, we have to kind of think ahead. We want x plus 2 once we pull out something, so that means we need to pull out the minus 4, which leaves us with x plus 2. So that's step 1 of grouping. And then each of these two terms are have an x plus 2 in common, times 5x squared is what's left here, minus 4 is what's left there. So now that's factored in. Again, resist the urge to keep going. That's not right. It's just, we were just told to factor the expression, so we're done. So don't make that mistake. Also, if it says solve, occasionally people stop right here and they don't solve. Remember, solve means to go all the way until you know what x is. All right, so that's the lesson on factoring quadratic equations.